In this video, we are going to design a tank level control system which alarms when the level of tank is less than 20 and when the level of tank is more than 80 liters. Okay, I'll show you how our front panel should look like. We should have something like this: a tank, a control to adjust the inlet flow, and also a control to adjust the outlet flow. I will explain about why I chose the unit liter per second, or I should say liters per second, doesn't matter. Okay, we need also to have two LEDs. Actually, one saying tank is empty, the other tank is full. When the level of tank is less than 20 liters, we should get this alarm. When it is more than 80 liters, we should get this alarm: tank is full. Okay, I'll also show you the solution, and I explain a little bit about it. Then we will solve this example together and actually find out more about this about it. Okay, you see, these are the controls. This minus is because the accumulated amount of water in the tank is actually the sum of the inlet flow and outlet flow. If we say the outlet flow is negative, and it should be like this. Actually, the flow in minus the flow out should be the amount of accumulated water in the tank. Okay, this plus here is actually our tank. I explained. Actually, in a tank, the level of tank in each moment is in fact the summation of the new added water plus the already level of water in the tank. For example, assume that we have 40 liters in the tank. Okay, when 10 liters is added, assume that there is no drainage. Okay, that we don't have any outlet flow. Okay, when a new actually a new flow coming into the tank, let's say 10 liters, then the tank the level of actually the volume of water in the tank will be 50 liters. You see, the tank is actually what it does is summing the previous value plus the new value. This is what tank does. And we use this principle here. I will explain about the rest later, why it is like that. Actually, we see together why I use this function here, this vi here. And another thing that you should know before I start the program is these actually LEDs. These are indicator of Boolean value. When the level of tank is more than 80, this LED will turn on, and when the level of tank is less than 20 meters or 20 liters, this LED will turn on. I will explain also about this. Let's explain it now. Actually, I told you that while loop repeats on and on till I push the stop button. Okay, when I add this function, this is wait vi or function. Sorry if I sometimes use function and sometimes vi. By both I mean from both I mean these gadgets that we use in LabVIEW. It is called in fact they are called vi, but sometimes I use function, but it's not wrong to use function for this anyway. Okay, when they use this vi here, each actually it's a delay function. I put a value of 1000. The unit of this is milliseconds. 1000 milliseconds is 1 second. It means each, when I put this function here, it means each loop lasts 1 second. Then we can say, yeah, each loop period is 1 second. That's why I put the unit of liter per second here, because here, for example, we put 5 as the inlet flow value, and each period of this loop is a second, then I can say, okay, this could be liter per second, actually 5 liter per second, because in each second 5 liters of water is added to the tank. That's why I put the liter per second here. Okay, let's start our program. Hello. Okay, sorry for the pause. We go and solve this. Okay, first I need a tank here. Resize it. I need a controller here. I put a control here. I need also control. Okay, I just rename it. Flow in liters per second. I need a controller also here. Let's say I put it here. Flow in, flow out, liters per second. Actually, you should be very specific about the units. Be always careful about the units you choose. This is a program just for learning and practice, but if you want to make a real program to calculate something, you should be very careful about the units you use. Here I told you that we chose the unit second because we make every loop, actually we make each iteration in a loop last 1 second. That's why I chose the unit per second here. Okay, I actually I insert also let me minimize this. I insert some photos to make our program a little more interesting and exciting. Copy this photo, paste it here. First I press Control T to have these two. Okay, let's say I have something like this. This is smaller, too big. Good. So add some photo here. And move it a little bit here. I have to also change the value of our tank here. Okay, everything seems fine. Are all in our front panel. In our block diagram, first of all, I need a control loop from programming, structures, while loop. I need a stop button here, create a control. Okay, I put my stop button here. Okay, as we discussed earlier, okay, I need a subtract here. Okay, actually flow in minus flow is the amount of water accumulated in the tank. Okay, let's say flow in minus flow is the incoming flow rate. Yeah, we can say something like that. Okay, I need also a tank. Okay, okay, this is added here. Okay, the volume in a tank, let's say uh, the level of tank is 0. Okay, we have 10 liters coming in, 5 liters coming out. Then the result of this will be 5. 5 liter will be accumulated here, and the level of our tank will be a 5 liter. Okay, for the next iteration, or let's say next second, the level of tank will be my current 5 liter plus the new 5 liters. Okay, this is our tank. I also make each iteration lasts 1 second by this function here. Create constant. Yeah, let's try this to see if it is working. Okay, I started our program 0 0. Of course, there shouldn't be any water here. We say okay, 6 meter, let's say 10 meter, and yeah, that's working. Okay, I make it 0. Okay, everything is fine. Okay, let me add something first of all to this. I add a digital display. You see, we have a level of minus 44. It actually